So now we're going to be solving 242 problem number and the name is valid anagram. The problem is easy. So let's go to a whiteboard. Okay. Let's try to understand the question first. Okay. So the question is given two strings S and T. S and T are two different strings. Return true if T is an anagram of S. We have to return true if anagram. Okay. If it is an anagram or false otherwise. Else false. Okay. So what is an anagram basically? Example, if S anagram. Okay, I'll do it over here. Anagram and Nagaram. If you look at the counts of variable or the counts of the letters we have over here, A for S, you look at S, A N A is gonna go. We have 1, 2, 3, 3 times A. N is for one time. G is for one time. R is for one time. And M is for one time. Okay. A is for 3 times. N is for one time. G is for one time. R is for one time. And M is for one time. And if you look at T, N is for one time. A is for 1, 2, 3 times. G is for how much times? 1. R is for one time again. R is for one time. M is for one time. If you look at this data and this data, they are equal, right? So that is basically anagrams. If you change the sequence, but the amount of letters or the letters which are similar or letters which are same, there is 3 times A, you have 3 times A. N is one time, N is one time, R is one time, R is one time. So that is anagram. If you look at this, rat and car, R is present, R is present, A is present, A is present, but T is not present. And here is C is present, right? So T is not equal to C. So this is not an anagram. Okay. So that is the question basically. So let's try to find the solution over here. So for finding the solution, there are multiple ways. The first solution is basically gonna be we're gonna sort everything out by using a Python function that is sorted and pass the string for S, and I'll write the solution over here. Write sorted S and sorted T. So what will basically happen over here is the output which we get. So when you sort this out, that's it. Anagrams. Okay. Sort this out. What are you gonna get? ANA. Sorting basically means we're gonna get first three A's together. Okay. We sort this A. Then we're gonna get A, B, C, D, E, F, G. We're gonna get G, H, I, J, K, L, M, N, O, L, M, N. A, B, C, D, E, F, G, H, I, J, K. Okay, whatever the number is, let's say if we get the output as whatever it is. Okay, let's see A, B, C, D, E, F, G, H, I, J, K, L, M, N. Okay, we're gonna get M over here, then N, M, N, O, P, Q, R. Okay, so this is what we're gonna get, right? And for sorting T, that's the same. G, M, N, R. Since both of them are same, it is an anagram. Since we are making some letters, some characters, or some word out of this character, some same number of characters and equal number of length, right? So this is an anagram. But if you look at this rat, if you sort this out, what you're gonna get A B C D. That is A is gonna come first, A B C D E F G H I J K Q P L M N O P Q R. Okay, so A is gonna come first, R then T, Q R T. No, R8. It is basically R80, right? So ATR, let's say, what are you gonna get? A C R. You look at this, the second element is not same, so it is not an anagram. Okay, so that is what we have to code first. There are multiple methods of doing this, but firstly we're gonna do this. So, and also the most important thing is the first and the foremost important thing, the easiest check we have to do is that both of the lengths should be same. Length of S should be length of T. If they are not same, it is not an anagram. That is the easiest first check we have to go through. So if length of S is not equal to length of T, then we have to return false, right? It is not an anagram, as simple as that. But if it is equal, we have to do something else. So we have to create a variable sorted S, and we will store the result of that particular sorting over here. To sort the S, sorted S. It's gonna return the output just like this. Okay, sorted S. Now we're gonna do the same for the other string, sorted underscore T is equal to sorted of T. Right, now what we have to do is, once we get this, now we just have to check if they are equal or not. Are the letters present at the element corresponding index same or not? As A is equals to A, is A is equals to A, is G is equals to G, M is equal to M, and N is equal to N, R is equal to R, or over here A is equals to A, T is equal not equal to C, right? So it's not an anagram. So that is the same thing we have to do. And so how do we do that? It is very simple. Okay, we just have to do return sorted underscore S. We're gonna directly use the return thing over here. It's gonna return true. If this is equal, we'll return true. Sorted underscore S, sorted underscore T. Okay, so let's run this. Case 1 and case 2 have got accepted. Also, let's talk about time complexity as well right now, or at the end, it would get tough to remember that, right? So, time complexity for this is basically, I'll just send that over here. Okay, lead code over here. The time complexity is basically n log n plus m log m. It is depending on the input, okay? Where n is the length of the string s, it's the length, okay? And this is basically m is basically the length of the input t, and it is o1 or on plus m depending on the sorting algorithm. Whatever algorithm is going to be used over here, that is the basically the space complexity. Okay, so now let's proceed on to the hash map method. Okay, let's proceed on to the hash map method. The code is running and it's fine. Okay, if you submit it, it will be submitted. So now let's go over here. Now let's do the second method. Okay, since we know what we have to code, like since we know what is exactly we have to do, now we will basically do another way, that is basically this. Okay, not this one, but actually this one. Okay, hash map. We'll use hash maps. Hash maps are basically dictionaries in Python. So we have to use dictionary over here. Okay, I'll write the code and explain it to you. Okay, explain line by line. So the first test is gonna be the same, that the length should be equal, right? But this method is all the code that will be changed. So first that we're gonna create two empty dictionaries to count the frequencies. Okay, I'll explain that to you. Count S and count. Why I'm doing it, I'll explain that to you. Count S and count T. Count S is going to store the frequency, okay, of string S, the number of the characters present. That is basically how much time A is present, how much time B is present, how much time C is present. And the string S is going to be stored in the dictionary count S. And in count T, it's going to store for string T. Okay, is that clear? Perfect. So now in the another step, what we're going to do is for I in range, okay, for I in range of length of S. Length of S is how much? 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. So it is basically we're going to do 6 iterations since it stopped just before it. Okay. So I'm going to write a line of code which is going to solve the problem. So try to understand it. I'll make you understand it. Don't worry. The count of S. Okay. Count of S. We're taking it over here. Hmm. Then S of I is equals to 1 plus, don't get scared, I'll explain it to you. If you don't know this function, don't know the method, count S dot get S of I my 0. Okay, I'll explain it to you. What is exactly happening over here? Let's copy this. I think you have understood over here. This thing is understood, right? For I in range of length, that we have to do 6 iterations. So, but what do we have to actually do? Let's understand it over here. Okay, so let's understand this step by step. Okay, count S. What was this? Dictionary, right? So then dictionary store the frequency of elements. Okay, the frequency of elements. And S of I, what is it? I, if you look at this, S is the input. Okay, Anagram. Okay, anagrams. Let's start from 0, 1, 2, 3, 4, 5, and 6, right? So S of I. So if you pass 0 over here, if S of I is 0, what will this S of I of 0 become? A, right? So what are we getting over here as a whole? This becomes A, right? So what are we getting as a whole? So count of A. Okay, count of A. 1 plus. Now count of S. Now we're using this get method. Count of S is basically the same dictionary over here. Okay. Now get. Okay. What are we doing with the help of get? Get is basically it tries to get the current count of S of I. And if S of I, if A, if this is A, if it is A, is not already a K or is not already a key in K of S, in count of S, if it is not already a key in count of S, then it returns a default value that is 0. Understood? I'll explain that to you again. count of s, right? Dot get s of I is a, right? Comma 0. S of 0 is basically a. Okay. Now dot get count s. So what does it become? So let's say count of s is an empty dictionary right now. Since we are in a first iteration, so what will happen over here? 1, we have this 1, okay, plus count s dot get a. Since it is empty, we don't have any a over here. A is not present, right? So what we're gonna get? A default value 1 plus 0. What does it become? 1. The count of a is 1, okay? Count of a is 1. So the key over here is a, value over here is 1. So a is equals to 1. Now let's do this for the other iteration n. The same is gonna happen. N is not present over here. So n will become 1. Now we come to a. Is a present over here? Yes, the count and count dictionary. A is present. So what are you gonna get? S of a. What is this value for a? We already have the value for a, that is 1. So what will happen? 1 plus 1. What will become a? The a will become 2. Now g is not present. So g will become 1. Since it is going to return a default value plus 1. R is not present. So R is 1. A. Now what is a? If you look at a is 2. But we already have the value that is already it is 2. But we have to add 1, right? If we get some output over here, that is 2. We'll get 2 count for the value a. Now this is going to become 3. Now m is not present, so is equals to m. Okay. So at the end, what we're going to get for this is basically a is equals to 3, n is equals to 1, g is equals to 1, r is equals to 1, m is equals to 1, and it is equals to the same thing for t string, right? To do this, we're going to get the same result. So it is an anagram, right? So that is what we're doing over here. We are counting it over here. Okay. Now that should be done same for that thing as well, right? Since count s of I, now we're gonna do for t of I. Let's do it over here. Let's copy the whole code. Now this will become count t of I, and okay. Now we just have to compare those two dictionaries, right? That is very simple. Get out all of the loops, get into the first indentation. Now return count of s is equals to count t. Should work fine. The parentheses do not match. Okay, I've opened a square braces, so it should run now fine. Line 6. Okay, we haven't declared this. It should be like this. This is also dictionary, this is also dictionary. Okay, perfect. The syntax was wrong for this declaration. Okay, so this is the code we got over here. This is fine. True, false. Okay. Now, if we talk about time and space complexity, you can look it over here. Neat code. Okay. N plus m. N is the length of the string, and m as the length of the string t. So basically we are going through each and every iteration, so it is depending on the length of the string for both of them. And since we have at most 26 different characters, right? 26 most different characters, we look at this. The maximum we can have this 26, right? 26. And this is gonna be maximum is gonna be 26, right? So it is fixed, right? O is equals to 1. It is fixed. It is not dependent on the input. The frequency is changing, but the size is same. So space is gonna remain same. Okay. Now let's do the third explanation, and that is gonna be with the help of what it is? Hash table using arrays, proper arrays. Okay. Now we're gonna use proper arrays. So the first condition stays the same as always. We don't have anything over there. So this is gonna be something special over here. Okay. Let's go over here. Okay, so let's write it away. So firstly, what we're gonna do is we're gonna compare the length. Okay. We're gonna compare the length of S and length of T. Okay. We're gonna compare it. Okay. What's the next step? We're gonna use the ASCII code over here to solve this problem. So let's say count is equals to 0 into 26. So there are 26 characters, right? From A to Z, there are 26 characters. So we are making a list basically to E to Z. That is, it is gonna have zeros at that representations. Okay, 0, 0, 0 until 26 times zeros. Okay. Now let's do the next step over here. Firstly, let's code it. Count is equals to 0 into 26. Okay. So the same step again for I in range of length of S. So here I'm gonna write a code. The logic is gonna be something. I'll explain the logic to you. Okay. Explain the logic. So ASCII starts from A. Okay. It starts from 97. B is 98. Okay. C is 99. D is 99. Okay. So let's search it over here. ASCII. Lowercase letter A is 97. Okay. A is 97 over here. B is 98. C is 99. Fine. So for that to happen, we are gonna write a very simple line of code over here to understand it. Okay. So let's understand how it's gonna work. Let's write the code first so I can make you understand. Okay. And I'll copy the code over there and then I will make you understand. Okay. So let's understand this. Let's copy this. Uh, let's go a bit up. Let's understand this line of code. This line of code. Okay. So what is happening over here? Break this down. This, 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 then this as a whole, then the operation. Okay. Right. So ORD of A is gonna return the ASCII value. So what is the ASCII value for this? That is 97. Right. Now ORD of S of I. Suppose let's say ORD of S of I, S of 0. Let's say S of I is currently 0. S of 0 is A, right? So A, ORD of A is how much? 97. This much is solved, right? So 97 minus 97 gives us 0. So count of 0 is equals to how much? Plus or is equal to 1. So already it was 0, so it's gonna increment to 1. Hmm. So now what we are basically doing is we are basically creating a list of found, okay, of 26 characters. Everything is 0, right? 0, 0, 0, 0, 0. Okay. So now the count of 0 will become 1 over here, right? Since we are adding, so everything with 0 is gonna be updated to 1, right? Everything is gonna be updated to 1. So now let's say we are coming across anagram text. The first A value has been stored, that is 0 is equals to 1. Now let's say we are coming across n. What is gonna happen next? Let's say this is gonna stay the same, right? This is gonna stay the same. Now what will happen over here? Let's search ASCII small n. 110. Okay. So this becomes 110. 110 minus 97 gives you 13. So this is gonna become 13. The count of 13 is equals to 1 now. Okay. So you can add it over here. Count of 13 is equals to 1. Now what is A again? Since count of 97, it is 97, right? 97 minus 97, that is 0. Since count of 0 is plus or is equals to 1, so we need to increment every other count. So this is gonna become 2, this is gonna become 2, this is gonna become 2, this is gonna become 2. Now for G, whatever it is, let's say it is 15. So 15 is gonna become 1. R is gonna become, let's say 17. So R is gonna become 1. A is gonna increment it, and A is now gonna be 3. That is 0 is gonna be 3 now. So every element present 0 is equal to 3. M is basically again not present, so let's say M is 12. That is gonna become 1. Okay. So the first thing is done, right? First thing is done. So you create everything, you create this final list out of you, right? This is for string s. Now what you have to do is you have to apply the same logic. Everything will be same, but just that we don't have to increment it. We have to decrement it. Okay, you have to decrement everything. Let's say if g comes, we're gonna make the g is 1 over here. We're gonna make the g to 0. Since and if a is over here, firstly a is gonna be 3, then we have occurrence of 3 times in anagram, that is string t, right? So 3 is gonna become 2, then it is gonna become 1, then it is gonna become 0. If every key value pair becomes zero, every key value pair becomes zero, then we have to return it. What do we have to return it? At if values in the count. Now we need to iterate through every part of the dictionary. Values and count. Okay, values in the count. Look at this. We're iterating through each and every value. Okay, value. Oh, we have to use for loop for values in the count. We're iterating to each and every count. Okay, every count key value pairs for every value in the value is not equals to zero. Then we're gonna return false. Or what do you have to return? Get out of each and every loop. Get out of it. Just a second. You don't have to add a loop over here, man. You don't have to add it inside this. So okay. If ends over here. Yeah, the count over here, it should also be away. It is not inside the if loop. If statement is not inside the if statement, then we have the for loop over here. So here we are returning the length. Here we are making a count dictionary. Okay. And count list basically. And then we are iterating through each and every key value pair. Okay. Each and every list, not key value pairs, man. For every values in count, for every values in count, for every values, for every values in count. If value is not equal to 0, return false. That the string is not equal, or else return true. This thing is gonna make a list, and this thing is gonna delete the list. If any of the key value pair is 1, that means the text is not similar. Different time, kind of different text, different letters are used. So that's what we are doing for every value in the count. If value is not is equals to 0, that means the value is different, that we have not been able to delete everything to 0. Then we're gonna return false. They are not equal, else return true. Let's run the statement. Let's run this code. The loop is wrong over here for I in range. Case 1 and case 2, right? Perfect. If you look at the time and the space complexities over here, O(n) plus n, it depends on the input. Okay. O(1), since we have at most 26 different characters, right? It cannot go higher than 26, right? Is only gonna be present one time, even though count is gonna increase. The keys are always gonna be the same. The space is always gonna be the same. And what do we have over here? The code. Okay. And O(n) plus n, time depends on the number of inputs, since we are just going through each and every element present, right? And we are gonna iterate through n, then we're gonna iterate through m. N is basically the length of the string. It depends on the length of the string, and it depends on the length of the string. Bigger notations. And O(1), since there are 26 different characters, it will never be 27 if the letters are small. It can be done differently for bigger characters. Okay. So let's submit the code now. 82%, 64%. Okay, it's fine. So this was the solution for the problem number, whatever it is. The problem name was anagrams. Okay.